we have to write a menu-driven program to perform 16-bit addition, subtraction, multiplication, and division. In the previous experiment, we have seen addition, multiplication, subtraction, and division of two 8-bit numbers. Now we are doing for 16-bit number, and it's a menu-driven program. So here we'll learn how to display output on the terminal. So before understanding the code, let's understand few of the concepts which are used into the code. So first thing is macros. Yes, so macros are like the procedures, but they exist only until your code is compiled. After compilation, all the macros are replaced with the real instructions. And the syntax for that is you have to write the name of the macro, whatever is the name you want, whatever name you want to give, you can give. Then write the keyword macro, and then the parameters you give, then body of the macro, and end it with the keyword endm. For example, display here is the name of the macro, this macro keyword and the parameters. Now here this is the macro body, and this we are ending the macro. So whenever you need a particular line of code, if you need a particular code into the program so many times, you can put that into macro so as to reduce number of lines into the code. Now here in this program we'll be taking inputs from the user because it's a manual driven program, so user has to select the choice, and we will be displaying output also onto the terminal. So for that we need to understand some of the keyboard interrupts. So that we here we'll be using int21h interrupt. So as in the experiment 1, we have seen one function of int21h where we were using uh, int21h to terminate the program, right? So for int21h, it will check the value of ah register. So whatever value is there into ah register, it will perform a different operation based on the value into ah register. So suppose if you want to take input from the user, so now we may want to take a single character as input, or we may want to take multiple inputs from the user. So based on that, if AH has 0A and then I call int21h, then it will keep taking inputs from the user until it's terminated by a $sign or null. And the input which user will be giving will be stored into register AL. Here if we put 01 into AH register, then it takes only one character from the user, and again that character which is taken as input, that will be stored into AL. Now suppose here user has pressed 5, so ASCII value of 5 will be stored into AL. Suppose user has pressed letter A, ASCII value of letter A will be stored into AL. So we'll have to convert that again into hexadecimal into our programs. Now if we need to display a message or some strings we need to display, for that AH should have 09H. So if AH has 09H and then we call int21H, then it displays a message which is terminated by $sign. And here in this case, when 09 is there, DX register we use. So whatever data we need to display, it has to be there into DX register or DL register in case of byte version. Okay, now let's see the program. So here again, the program is to write a menu-driven program we are writing for adding, subtracting, multiplying, or dividing to 16-bit numbers. So here, dot data here is the data section. Now inside the data section, we create all the variables. So first, let's take two variables for the two numbers. So A and B are the two variables which are having 16-bit numbers, and DW is the data type for these variables. DW is defined word, so it can take 16-bit data. So as we have to add two 16-bit numbers, I'm taking data type as DW. In the previous experiment, if you see, we were adding two 8-bit numbers. The data type which we used was DB, defined byte. So next here we are creating a string menu. So here it will keep on taking values from the user until a $sign is there. So we will print it later, but for here we are defining it. So it will display menu. Now here this 10D and 13D are for line change and carriage return. So it will the cursor will after displaying menu, the cursor will come to the starting of the next line. So now in the next line it will print add two numbers, then subtract two numbers, multiply, divide two numbers, exit, and then uh, enter your choice. Then again I am declaring few more strings m1, m2, m3, m4. These are to display the output. So the m1 says sum is then similarly difference, product, and quotient we are displaying. Now I need to display all of these strings. I need to print all of these strings. Now to print that, there's a procedure which we need to follow. So that we need to follow again and again, right, for every string. So we are writing a macro for printing the string. Now if you see uh, here, we have discussed that if I need to display a message using int21h interrupt, AH should have 09h. Now, and the characters which we want to display, that has to be there into DX register, right? So now here I'm defining the macro. Name of the macro is print, and now here now whenever we need to display any string, so here this xx is the parameter. So here I'll be writing the name of the string which I have to display. So menu m1 m2 while I'll be calling this macro. So then I need to put the offset address or the effective address of that particular string. So and that address should be there into dx register, right? So we will be uh, putting effective address of this particular string into dx register, and then whatever we need to display, that has to be there into dx register only for this int21h to display the interrupt, to display the string. So then ah has 09, and then we are calling int21h. So this will print the particular string. Now here this end m represents the end of this macro. Now we are starting with the code segment. First thing we do is to initialize the data segment. So here we are starting with the code segment. Initialize the data segment. I cannot put the to initialize that. I need to put all the data into the segment register of the data segment. I cannot immediate addressing mode cannot be used with the segment registers. So the data has to go through a general purpose register. So first we'll move the data into AX register, and then from AX we are moving into DS register. Now here we'll be using labels. So this main and column, this is a label. So now here I am using this, I'm calling this macro which we have defined here. So print menu. This menu is the string which we have created here. So it will print menu, then it will come to the next line, add two numbers, subtract, multiply, everything it will until enter your choice. Here it will print. Now user has to enter a particular value 1, 2, 3, 4, 5. So we need to write that code. Now we need to take only one character as input, right? So that for that AH should have 01H, right? And that character will come into AL register. So now move AH comma 01H, and then I'll call int21H. So then user will be allowed to whatever character user is selecting, like whatever number case user is selecting, that will come into AL register. So now we'll have to check user is typed which number 1, 2, 3, 4, 5, which number user is typed. So that number is stored into AL register. So we will compare AL ka value with 1, 2, 3, 4 or 5. So whatever is the AL value, based on that we'll be going to a particular case. So JE, jump if equal. So if AL is equal to 1, we will jump to case 1. If AL is equal to 2, we'll go to case 2, case 3, case 4. So case 1, 2, 3 and 4 are defined later into the program. For case 1 is for addition, 2 for subtraction, 3 for multiplication, and 4 for division. And if user is selected for, and if user is selecting case 5, it will go to label exit. Now let's define all of these labels. So this exit means we want to exit the program, we want to terminate the program. To terminate the program, again we'll be using an int21h interrupt. For that, AH should have 4C value, 4C. So here we are writing this script. Now if user is selecting case 1, so it will jump to, if user is if user has entered 1, it will jump to case 1. So it will come directly here at case 1 label. Now case 1 is for addition. So now here we have declared one macro. So sum is, so this will be printed, and then at the end the output will be displayed. So here I am printing M1. Now A and B are the two variables which we declared for here in the data segment A and B, which are having our two 16-bit values, 2222 and 1111H. So now I am just moving those, because I cannot write add a comma b. I cannot give two variables here with the add instruction. So I am moving the values into ax and bx registers, and then I am adding them. Now this ax has the uh, result, 16-bit result. Now I need to display those the results I need to display, right? So the in hexadecimal that will be 4 digits, right? So now to print that, whenever the value is print, if suppose now the result is 3333h. So or let's consider two different numbers, like uh, uh, suppose our answer is 1234h. So whenever that answer is displayed on the terminals, first of all 1 will be printed, then 2 will be printed, then 3 4, that way it will be printed, right? So first of all MSB will be printed, and then we will move towards LSB. So here also we will be following the same concept. So first we need to display the MSB first. So here first we need to display 4 digits. So in CH register I am taking count as 4. Now we need to display the MSB first. Now for that we want MSB to come at LSB position. So if I rotate a number by, if this we've already discussed into the class, if we rotate a 16-bit number 4 times, the MSB will come to LSB. So so here I need to rotate left the number 4 times. So this count 4 I am giving into CL register. And we have already discussed, when we are using this instruction rotate left, we have to give count into CL register. So now uh, my result was there into AX register, right? Now I am moving it into BX register, because this AX register I need later, because for int21h or for some other reasons I need this AH register later into the program. So I am displaying the I am transferring the result from AX into BX. Now we are starting a new label, because the procedure which we are going to do now, we have to do it for all the 4. We need to display all the 4 digits, right? So we need to do it again and again. So I'm starting a new label. I'll jump to this label again. So now rotate bx is our result, by cl is 4, the count to roll the numbers. We need to rotate it 4 times so that the MSB comes to LSB. Now MSB has come to LSB at this position. Now I need to now in BX register MSB has come to LSB. So I am interested only in the lower part of the lower 8 bits of the BX register. So I am taking BL, and then I am moving that data into DL register. Why DL only? Because if you have seen that here we discussed that if I need to display a message, that data should be there into DL register, right? So here I'll be displaying a number, so that number should be into DL register. So I'm loading that LSB into DL register. Now LSB contains 8 bits, like 2 digits it contains. For now I need to display only 1 digit, right? So I need to get only the LSB. So to get LSB, I am ending this value of DL register with 0FH. So whenever we end a number with 0, it becomes 0. So first, okay. So here after this operation we will be having only the LSB which we want to display. Now we need to check whether uh, the LSB is a number or a alphabet, because whatever we have into DL, if I print that directly, its ASCII value will be printed. We will need to print that into the decimal format. So here we will compare the DL value. So with 09. So compare operation will do what? It will subtract this value. So we will, here we need, if the value is between 0 to 9, we need to add 30 to that number, and if the value is between A to F, if it's a letter A to F, then we need to add 37H to get its ASCII value. So now here we'll compare whether the values the suppose now consider that the result was 2 here. So it will do 2 minus 9. So the result is, so the 2 is less than 9 here. So it will check jump if JBE, means jump if below or equal. So this value is below 9, right? So it has to add only 30 to it. So it has to add 30. So it will move to label L4. So it will come directly here, this line will be skipped. So it will come to label 4, and here it will add 30 into that value. So now DL will contain whatever is the alphabet. So we assume that if it has 2, so 2 plus 30, it will become 32, which is ASCII value of 2. So to display that, we need to give ASCII value into DL register. So again, to display AH should have 0 2, and then I am calling INT21H. Now assume if here there was a letter. So let's say if A is here in DL register. So it will compare DL the value with 9. So A, which is 10 basically in decimal. So 10 is greater than 9. So this condition will not be satisfied. Jump if below or equal. So 10 is not below 9, right? Or 10 is not equal to 9. So this line will be skipped. So it will not jump to this label directly. It will execute this line. So first it will add 7 into DL. So and then it will, after executing this, it will come here and then it will add 30 also into DL. So 30 plus 7, total 37 are added if it's a letter between A to F. And then again it will be displayed. So this is how we have displayed only only MSB right now, right? And to display MSB, we are moving it to LSB. So now again in this count, we have declared here CH equals to 4. This was number of digits I need to display. So right now I have displayed 1 digit. After this, again I need to display 3 more digits. So I will decrement this count now. So here we have decremented the count, and we will check if the count is we will repeat this procedure until the count is 0. So here we are checking jump if not 0. If the count is not 0, you have to jump to label L2. So here now the count will become 3. It will again come L2. L2 is doing what again? Again bring the MSB to the LSB. So the next number will come to LSB, and again we are performing the same procedure and displaying that number. So this will be performed, again count will be decremented, the count will become 2. Then 1 and 0. When the count will become 0, so this condition will not be satisfied. So it will not go here on L2 and it will come to the next line. Now the next line says jump to label main. So main was this starting label. So which was printing the menu and taking the choice from the user. So again user will select one of the options. So whatever case user will select, based on that it will go to that particular label. So just now we have seen the code for case 1. Same code is there for case 2, same logic is there. So let's see for case 2. So for case 2, again I am printing the string which was supposed for, which we were supposed to print for case 2. So M2 says subtraction is, and then we will display the value. So A and B are the two variables which are having two 16-bit values. I am performing subtraction. Then again the same procedure we have followed. We need to display the numbers. So total how many numbers I need to display. So that many times I'll run this loop. So the count I am giving into CH register. 4 times 4 digits I need to display. And then I need to rotate left the 16-bit number 4 times so that MSB comes to LSB. So I need to rotate it 4 times. So for rotation, this count is given into CL register. Now again I am moving my result into result was stored into AX register. I am moving it into BX register because I need this AH register later for displaying the character. Now again the same procedure we are following to display the characters which we have used into the case 1, and then we are again jumping to main label. Label main is again displaying the menu and comparing the case which user has entered. Now let's see the case 3, which is for multiplication. Now case 3, I am printing the string that which says multiplication is or the product is. Now again move two numbers a and b which are having two 16-bit values into ax and bx register. Multiply bx. Here we give only one operand in multiplication operation. Another operand will be the accumulator. So here ax we have put the value into ax. So it will multiply ax and bx, and the result will be two 16-bit values we are multiplying, right? The result will be a 32-bit value. So that will be stored into dx and ax register. So our result is into dx and ax register. Now these dx and ax registers I need later into the program for INT21H. So I am transferring the result into some different registers. From ax I am transferring into si, and dx data I am transferring into bx register. Now I need to display values of both the SI and BX register. Now the procedure which we have used in the previous cases for displaying the value, I have to use that procedure 2 times, right, for 2 registers. So I am giving that count 2 into a register DH. Now again the same procedure we are using. Number of digits we need to display 4. Then we need to rotate the numbers 4 times, so MSB comes to LSB. For that count I am giving into CL. Now here again I am following this same procedure to display the character, and I am decrementing the count here. So if the count is like here, it will keep on displaying the values until the count is 0. So we have given count 2, so two times it will display the values. So sorry, this count is for this ch count is for number of digits we need to display. So this ch will, it was 4 initially. It was 4 initially. So it will become 4, 3, 2, 1. So it will display 4 digits, and then here I am decrementing this main this count. So this count is to display the values of 2 registers because our result is 32-bit result. So Psi and Bx, two 16-bit registers I need to display. So if here it will compare, if the DH is 0, then it will compare DH with 0, and then it will again move SI ka value, which is the next register I need to display, into BX again, because here the code which we have written is with reference to BX. And again jump to the main label. Again in the main label the menu is printed and it will compare the cases which user has entered. So now let's see case 4, which is used for division. So here we are printing the string for case 4. Then we are taking values of ax and bx, uh, values of variable a and b into ax and bx variable. And then DL and DH registers are having some values right now, right, from the previous, if we have used any other case before this. So we need to put that, we need to put 0 into that, and then I'm performing division. So now the result will be stored into AX register. So quotient will be into AL and remainder into AH register. Again the same procedure, I need to display this AX register. So my result is into AX register. I am moving it into BX register. Again the same procedure we have used to display the values. And again we are moving to the main label. Right here in the main label we have 5 cases. Case 1 for addition, subtraction, multiplication, division we have seen. In all the cases we have used the same procedure to display the output, and one case is exit, which terminates the program. To see the output, open DOS box. The program is saved into a folder named tasm, so I'm moving to that directory. Now to uh, run the program, tasm space file name. So we have saved the program with exp2.asm. .asm should be the extension of the file. If you have any errors into your program, at this here you will see the error messages. Here we don't have any error. Now we will link the program. For that, t-link space file name exp2. Then now, in the previous experiment, we have seen the debugger. We were we were executing the code line by line. Now here, this time we need to see the output into the terminal. So we don't want to debug it. So we will not write. Earlier we were writing td space experiment name. So here we will not write td. We will directly write the experiment name. So exp2. Now here you can see the menu, and these are the strings which we have displayed. Enter your choice. Now user will enter 1 2 3 4. So let's enter 1 first. Okay, the values which we've taken into the program are 2 2 2 2 and the other value is 1 1 1 1. So I'm selecting choice 1. So you can see that sum is 3 3 3 3. If I select choice 2, uh, the difference is 1 1 1 1. If I select choice 3, I can see a 32-bit result. The choice 4, you can see the quotient 2. If I press choice 5, it will exit the program.